Okay, guys, I'm going to go over some of the most commonly missed problems from your Edge Elastics Unit 6, Week 2. I'm starting with the Edge Elastic on determining sample space, and this is number 4. So in this question, it says you pick a card and pick a marble. The very first thing we need to determine is it independent or dependent, because that's going to determine how we set up our ratios for probability. If we pick a card and pick a marble, these have nothing to do with each other, so we would say that these are independent. One event does not affect the other. It says, how many possible outcomes are there? Well, if we look at the number of outcomes in the cards, there are 5. And with the marbles, there are 2. And our fundamental counting principle tells me that I can multiply these together and get 10. So our answer should have been 10. Okay, in number 10 on the same edge elastic determining sample space, it tells us that what is the total number of outcomes in 2 dice. So if we think about those, also, those are independent. If I roll 2 dice, what I get on one has nothing to do with what I get on the other. So I'm going to know that the first dice has 6 outcomes, and I'm going to multiply it by the number of outcomes on the second dice, which is also 6. And that gives me an answer of 36. So choice D was correct. Okay, I'm moving on to the edge elastic on tree diagrams. This is number 2 on that particular checkpoint. It says that Jamie rolls a number cube and spins a colored spinner. The spinner is divided into 3 equal sections, and the tree diagram shows all the outcomes. So you can see that we have the number cube, 1, 2, 3, 4, 5, 6, and then for each you can get red, blue, or green. Okay, you were looking for the statements that were true. So in the first statement, it says that the probability of Jamie rolling a 5 and the spinner landing on red is 1/9. Well, if we look at where the spinner lands on 5 and there's a red, that is in one location out of how many different options. I can count from my tree diagram that there are 3, 6, 9, 12, 15, 18 different outcomes. So that answer actually would have been 1 out of 18, not 1 out of 9. Moving on to choice B, the probability of rolling a 3 and the spinner landing on blue. Well, that only occurs in one location also. So that also would have been 1 out of 18. So that answer is not correct. The probability of a 2 or a 3 on the number cube and green. Well, if I look at where I could roll a 2 or a 3 and green, that's going to be a 2 and green right here. That's one location. Or a 3 and green. That's another location. So that could have happened in 2 places. 2 events make that outcome true out of 18, which simplifies to 1/9. In that answer choice, it actually said that that was 1/18. So that is also false. In choice D, it says the probability of rolling an even number on the number cube and the spinner landing on blue is 1/6. So an even number would be 2, 4, or 6, excuse me, 2, 4, or 6, and we were landing on blue. So that's going to happen here, 2 and blue, 4 and blue, 6 and blue. So that is 3 places out of 18. So if I look at my answer choice, it said 1 out of 18, which is again false. Moving on to choice D, an even number and landing on blue. So 2, 4, or 6, that was 3/18. which does simplify to 1/6. So choice D would be correct. If I'm looking at choice E, it says the probability of rolling a 1 and the spinner landing on blue or green. So this time we're looking only at the number 1 and blue and 1 and green. So that happens in 2 places. So that would be 2 out of 18, which is 1/9. And let's go back to our answer. It does say that is 1/9. So in this answer choice, it should have been D or E. Okay, I'm looking at the table here to determine what is the probability that we will end up with bow ties, cheese sauce, or both. So if I look at the total outcomes possible on this table, I know that there are 5 by 4, there are 20 outcomes. So that is going to be my denominator. So we know that it's out of 20. I want to look at where I have bow ties, cheese sauce, or both. So if I just start here with bow ties, I've got 1, 2, 3, 4 places. Cheese sauce, I've got 1, I've already counted this, 2, 3, 4 places. This was an overlap, so this is where both would occur. But if I add those together, I have again 1, 2, 3, 4, 5, 6, 7, 8 places where that event would be true. If I simplify, that becomes 2/5, and that is my answer. Okay, in this question, we're using the fundamental counting principle, but we'll notice that if we read carefully, we'll realize that this is actually a dependent event. So it says there are 7 clarinet players in the concert band. In how many ways can they be seated in 7 chairs at a concert? So if I think about this, if I have 7 chairs, 1, 2, 3, 4, 5, 6, 7, okay? And there are 7 clarinet players, so there's going to be 1 to fill every seat. In the first seat, there are 7 options of people that could fill that seat. Once that seat is filled, it now has an impact on who can fill the other seats. So this is a dependent event. There are only now 6 players available to fill the rest of the seats. 5 players, 4, then 3, then 2, then 1. If I multiply all of these together, my fundamental counting principle says that I can multiply the number of outcomes possible for each event, then I will get my answer. And I get 5,040, which is correct. Okay, let's look at the final edge elastic you had last week, and that was independent and dependent events. This was your checkpoint. This is number 2. It says a die is rolled 3 times. What is the probability of getting 1 on the first roll, a 2 on the second roll, and a 3 on the third roll? So if I think about that, the very first thing again is to determine, is it independent or dependent? Well, rolling a die is considered independent. What I get on one roll does not affect the outcome of my second or my third roll. So what is the probability of getting a 1, a 2, and then a 3? So I'm going to have 3 different events, and I'm going to need to multiply those together, okay? So the first event is probability of getting a 1 is 1 out of 6. The probability of getting a 2 is also 1 out of 6, and the probability of getting a 3 is 1 out of 6. So if I multiply those together, I'm going to get 6 times 6 times 6 in my denominator and 1 times 1 times 1 in my numerator. So my answer would be 1 out of 216. Okay, this is number 6 and it says a marble is picked at random without putting the first marble back. That's important because, again, our first decision, is this independent or dependent? If we are not putting the first marble back, we've now created a dependent event. So we've got a dependent event because the marble is not being replaced. Then we pick a second marble. It says find the probability that the first marble picked is green. So the probability of a green and then a red. Okay, so let's start with our probability of green. The probability of getting a green is 3 out of 6. We could simplify that. The next ratio now assumes that a green was picked. This is a dependent event. I always say if it's dependent, your denominator is going to go down. Dependent denominator down. So we're going to assume that that green is gone. We're going to have picked a green and now it is no longer there. So now we still have 2 reds, but now we only have 5 marbles. Okay, so we end up with 1/2 times 2/5, which gives us 2/10, which is 1/5 simplified. Okay, now it does ask us to answer as a percentage, so this would be 20%. Okay, for this example, again, we're looking at marbles, and it says we have 3 red, 4 blue, and 5 yellow. So I'm going to just kind of draw this out for you. So we've got 3 red, we've got 4 blue, and we have 5 yellow. Okay. In this experiment, you select a marble, record it, and place it back into the bag. This is different than the one we just worked in question number 6. This one says we're going to place it back into the bag. This makes this an independent event because whatever we get in the first, it doesn't matter, we're putting it right back. And then we select a second marble. So again, we have 2 events that we're going to be multiplying together. What's the probability that you draw 2 blue? Well, in the first event, what's the probability of getting a blue? 4 out of 12. Okay, we're going to put that blue right back. We don't have to cross it out. So then the probability of getting a blue again is also 4 out of 12. So this becomes 1/3 times 1/3. Your answer is 1/9. Okay, number 17 says you pick a card at random. Without putting the first card back, you pick a second card. So that concept again of not returning the card, it says without putting it back, we've now created a dependent event. We want to know what's the probability of getting an orange and then a green. So we have 2 events that are happening. It's dependent. The probability of getting an orange on the first pick is 2 out of 4. So we're going to assume that that occurred. We're going to assume that we took that orange, we're not putting it back in the deck, and now we want to know what's the probability of getting a green. Well, that would be 1 green out of 3 cards remaining. So our answer would be 2 out of 12, which simplifies to 1/6. So now that I've worked a few of the most commonly missed problems, it would be beneficial for you to go back and review any other problems that you missed. Can you find your mistakes? Use this as a way to study this week before your test next week.